Welcome to Joe Time, your ultimate destination for intriguing and enlightening content on everything space. Embark on this journey with me as we unravel the marvels of the cosmos right on your screen. It's Joe Time. A black hole is formed through a process known as stellar collapse. To understand this process, let's start with the life cycle of a massive star. Stellar formation. A black hole is created from the remnants of a massive star, typically one that is much more massive than our Sun. These massive stars form through the gravitational collapse of a dense region within a molecular cloud. Gravity causes the cloud to contract and heat up, eventually leading to the formation of a protostar. Output: main sequence. The protostar continues to collapse under its own gravity until the central temperature and pressure become high enough to sustain nuclear fusion. At this point, the star enters the main sequence phase, where it generates energy by fusing hydrogen into helium in its core. The balance between gravity pulling inward and the energy generated by fusion pushing outward keeps the star stable. Nuclear fusion. During its main sequence phase, the star fuses lighter elements into progressively heavier ones. When it exhausts its hydrogen fuel in the core, the star undergoes further collapse and fusion reactions occur in shells surrounding the core, producing heavier elements like helium, carbon, oxygen, and so on. Iron core formation. Eventually, after several stages of fusion, the star's core is primarily composed of iron. Unlike lighter elements, iron cannot release energy through fusion reactions, so nuclear fusion ceases within the core. The core no longer generates the energy needed to counteract gravity, resulting in the core's collapse. Supernova Explosion. The core collapse triggers an explosive event known as a supernova. The outer layers of the star are blown away, while the core collapses inward. The supernova explosion releases an immense amount of energy, briefly outshining an entire galaxy. Formation of a black hole. The fate of the star's core depends on its mass. If the core's mass is below a certain threshold, known as the Tolman-Oppenheimer-Volkoff limit, it will become a collapsed neutron star. However, if the core's mass exceeds this limit, the collapse continues until it forms a singularity, a point of infinite density, at the center. This singularity is surrounded by an event horizon, which defines the boundary of a black hole, a region from which nothing, including light, can escape. It's important to note that the process of black hole formation is still an active area of research, and there are several aspects that are not yet fully understood. As we reach the end of our cosmic journey, remember to like, comment, and subscribe to Joe Time to stay connected with the wonders of space. Don't miss out on future adventures, hit that notification bell, and join our community of space enthusiasts. Thank you for watching, and until our next celestial encounter, keep exploring with Joe Time.